Welcome to This Explainer. Today, we're diving straight into a journey that is honestly going to push the very limits of your logic. We're zooming out from the cozy, familiar bounds of our own solar system all the way out to the unimaginably massive structures of the wider universe. We're going to map out a cosmic scale that, well, it completely defies ordinary comprehension. And by the end of this, I promise you, your perspective on our place in the cosmos is going to be completely redefined. So let's jump right in. To kick things off, consider a question that might initially sound a bit absurd. Is our sun actually tiny? Now, calling our host star tiny seems ridiculous, right? I mean, it's a giant ball of fire. But the answer to this question is really the crucial first step in unlocking the true humbling scale of the universe we live in. Section 1. Our sun's true scale. To truly grasp the extremes of the universe, we first need to set a baseline. So think about Earth, everything we know, every mountain range, every single ocean, every continent. Now, imagine a hollow sphere the exact size of the sun. You could take 1.3 million Earths and literally pour them inside that single sphere. The sheer volume is already starting to slip beyond our everyday intuition, isn't it? By comparison, our home planet is practically microscopic. But hold on, because as overwhelmingly massive as 1.3 million Earth sounds, we have to immediately zoom out again. In the grand scheme of this infinite universe, our giant sun, it's actually smaller than a single grain of sand. Think about that for a second. The realization that our entire existence orbits a star that doesn't even register on the true cosmic scale is a perfect foundation for what we're about to explore next.
Section 2. The largest known star. Say hello to UY Scuti. This hypergiant star is located approximately 9,500 light-years away from Earth. Sitting deep within the cosmos, the physical dimensions of this absolute behemoth are something that completely redefine our understanding of what a star can actually be. To really picture its size, imagine taking our sun out of the center of our solar system and dropping UY Scuti right into its place. It wouldn't just swallow the Earth. Oh no. It would instantly consume Mercury, Venus, Earth, and Mars. The edge of this single star would push so far out into space that it would completely consume the entire orbit of Jupiter. Just one single star taking up that much physical real estate. Absolutely mind-blowing.
Okay, let's put this into a perspective we can kind of relate to. If you flew a standard commercial airplane at 900 kilometers per hour around the equator of our sun, the trip would take just about 6 hours. Not too bad, right? But flying that exact same plane at that exact same speed around the circumference of UY Scuti, it would take a staggering 1,100 years. You'd literally have generations of pilots born, living, and dying in transit before completing a single lap around this thing. Moving right along to Section 3, the most massive galaxies.
So stars, even massive hypergiants like UY Scuti, are really just individual components, the basic building blocks of much, much larger structures. To understand the scale of entire galaxies, let's start with our home again. Our own Milky Way galaxy spreads across a whopping 100,000 light-years of space. It contains all the stars you see in the night sky, including our local sun and giant anomalies like UY Scuti.
But just as UY Scuti dwarfed our sun, there are structures out there that dwarf our entire galaxy. Astronomers have discovered a radio galaxy named Alcyoneus. It is the largest known radio galaxy ever discovered. And let me tell you, it makes our 100,000 light-year wide Milky Way look like an insignificant little anomaly. 16.3 million. This absolute leviathan of a galaxy spans an unbelievable 16 million light-years across. Remember, light is literally the fastest thing in existence, yet it still takes over 16 million years just to travel from one edge of Alcyoneus to the other. When we look at structures of this magnitude, the physics and the distances involved, they just kind of stop making sense to our terrestrial brains. And you know, it's not just about physical width, it's about the sheer volume of matter contained within these bounds. Our Milky Way holds a very respectable few hundred billion stars, but compare that to the colossal galaxy known as IC 1101. This giant holds a jaw-dropping 100 trillion stars. Let that sink in. 100 trillion individual suns, completely eclipsing anything we consider normal in our local galactic neighborhood. The disparity in sheer matter here is just profound.
Section 4. A drop in the ocean.
When you stack it all up together, from fitting 1.3 million Earths into our sun, to finding stars that would swallow Jupiter's orbit, to galaxies harboring 100 trillion stars, a very distinct reality comes into focus. Our Earth, our giant sun, and even our entire Milky Way galaxy are not even a single speck in the face of this unknown and infinite cosmos. We are, for all intents and purposes, vanishingly small. But hey, the fact that we're here, conscious, and actively mapping out these impossible scales, that's an incredible testament to the power of human curiosity.
Because despite all our advanced telescopes, our complex mathematics, and our discoveries of titans like UY Scuti and Alcyoneus, what we know about the universe is a mere drop, and what we don't know is an entire ocean. It leaves us with a deeply unsettling but honestly thrilling realization to conclude this explainer. If galaxies of 100 trillion stars are just what we can currently see, what other incomprehensible structures are lurking out there in the dark, unmapped oceans of space, just waiting to shatter our understanding of reality all over again?